Hi, everyone, and welcome to Tools to Start Utilizing Machine Learning, the first in the series that covers the stages of your analytics journey. So since it's the first in the series, let me kick off with machine learning. What is it and what is its value? So as you can see, the formal definition there, it's the application of algorithms such that a computer learns from experience to improve the performance of a specific task. And it's being used everywhere from credit card fraud detection all the way to your Netflix recommendations. And what's its value? So at Thorogood, a data and analytics company, where do we see its value? Well, we work with consumer goods firms, banking firms, insurance, pharmaceuticals, and we find that at this point in time, many firms have a really good grasp of what happened. They're able to do descriptive analytics really easily. So look at the history and hindsight and see what happened and try and understand that. But you can see on the sort of value curve of analytics, that's only the first stage. And really, a lot of firms, I think, really want to move up the value chain there to understand, okay, diagnostically, why did something happen? What's going to happen next? And then how can we actually make decisions and influence things to get to our desired outcome as well? But you can see on the x-axis there, that comes with increasing difficulty. And machine learning really sort of enables companies to do that. It reduces the difficulty level to actually move up that curve. So if that sounds interesting to you, I'll run through a couple of tools that can help you get started using machine learning. To start off with, I'll just run through like a generic example of how machine learning works. So I'll use structured data set as an example. So what you might start off with is an initial data set. So like I said, it would be structured data in this case. Maybe it's for the rental market in London. So you've got different features of different listings of properties in London for rent. So you've got number of bedrooms, number of bathrooms, square footage, distance from the city centre, maybe what zone it's in, whether it's near a tube stop, all of that. And then you have the label, and that would be the thing that you're trying to predict. So in this case, it could be the price of those properties. So what you do is you have that whole data set with all the features and the prices, and then you split it up into training and test data. And then with the training data, you apply machine learning to create a model that's going to allow you to feed in features like bedrooms, bathrooms, zone, number of tube stops, etc., to create a model that's going to be able to feed in those features and then let you predict the price of that London property. Then once you've created that model, you feed in your test data. So you feed in the features of your test data. And then through those features, it's going to be able to predict the price. So you're going to feed in, like I said, whether it's got 3 bedrooms, 2 bathrooms, and it's in zone 3, it's going to be able to predict the price of that. And then you can evaluate the accuracy of that prediction by comparing the actual price of that London property with what you've predicted it as in your test data set. And then if it's a pretty accurate model, if that's what you've evaluated it as, then you can go and apply that model elsewhere in London. So you could maybe go and try to find out particularly undervalued properties in London, something like that. But if the model doesn't seem quite up to scratch for accuracy, you might want to iterate over it. You might want to bring in different features. You might want to add more data. You might want to try a different model type. Basically, the sort of world's your oyster when it comes to options with machine learning. So again, if that sounds interesting, here's some tools that can get you started. The first one is the simplest one. It's basically automated ML. And that's where almost all of the process for, splitting your data, training it, testing it, evaluating is handled completely for you. So you just prepare your data, you feed the data in, you maybe select a couple of parameters, and then you let the tool do the rest. I'll do a quick demo of that after this slide, but I'll demo it using GCP and Vertex and its tool Vertex AI. Then we also have sort of the next stage, which is low-code custom ML model development, where you actually build and experiment with machine learning models using click, drag, and drop functionality. So it's much more hands-on than AutoML. You're doing a lot of the different steps. You're splitting the data. You're picking a model type. You're choosing sort of what set to train on. You're maybe doing some of the feature engineering yourself as well, but you don't need to know any code. Or there might be a couple of cases where you need to do a little bit of like SQL or a little bit of code, but really it's a much simpler process where you're much more hands-on and involved in the creation of the model. And a good example of that is Microsoft's Azure Machine Learning Studio, which I'll use in the demo as well. Then the final stage is really to the point where you're coding in notebooks. So coding custom ML model development, you have much more control of your Model development, very few limitations so long as you know how to write the code. And really, it's the hardest and most complex aspect to creating machine learning modeling experiments. Databricks is a really good tool for this. It runs on all three clouds. It handles data engineering really well as well. It's a real leader in the space of machine learning as well. So with that, let me demo AutoML, low code, and then coding. I'll go here first to Vertex AI in Google Cloud. I'm just going to show you how easy it is to start an AutoML model. So I just hit create, I select the data set, and it's going to be red wine quality, and it's going to be low, medium, or high as the thing I'm trying to guess. So I choose the objective, classification, or regression. I choose classification and hit continue, and then name red wine quality, don't need data description, and the target column in this case is going to be quality. So quality is either low, medium, or high. So there's three classes. So I want to be able to predict that classification. And these are the features that are going to feed in. So alcohol level, citric acid, pH, sulfates, all of these, everything here is going to feed into my model as features. And then here I just set the budget. It's a very small data set, so I only need the minimum number of hours. And then I can hit start training straight away. So while that starts, you can see that's kicked off. You can see I have another one already kicked off. Let me show you one that's already been done. So here it is here. So it's red wine quality LMH, similar to the one I've just kicked off. And you can actually see the results of the testing here. So you can see that when the true label is medium, so when medium is the actual quality of the red wine, our model that's created in AutoML is able to predict that correctly 97% of the time. That's the headline. It gets a little worse. So whenever the true label is high, it's only predicting high about half the time. Whenever the true label is low, so whenever the wine is of low quality, our model is only able to predict that 17% of the time. So you can see it has a little bit of work to do. You'd probably want to bring in other type of features, like maybe type of grape or region that it's come from, other things that definitely affect the value and quality of wine. We can see here feature importance. You can see that alcohol has been deemed the most important feature, so the strongest driving factor in the quality of the wine as well. And then we have a lot of different scores here that will allow us to compare with other models as well in a sort of normalized way. Low code here is where you're actually building up all the steps of the model. So all of this is drag, drop, and click. So what I've got here is flight delays data. So I've got time of the flight, the carrier, the origin airport, the destination airport. And the thing I'm trying to predict is whether the arrival of the flight was delayed by more than 15 minutes or not. So 1 is when it is, and 0 is when it isn't. So what I've got here is splitting the data, picking my model type, training the model, scoring it, evaluating. What I'm going to add as well is just another step called select columns in dataset. And I'm just going to join that up, and it should allow me to select columns. So include all columns there, but add a second row and exclude certain columns here. So I want to exclude departure delay. I want to exclude departure delay 15. I want to exclude arrival delay, and I want to exclude cancelled. And I want to exclude these because I want the model to be based solely off time of year, the carrier, origin airport, and destination airport, as well as time of day, because I want to be able to predict, say, a month in advance whether a flight's likely to be delayed. And actually, some of this information, such as whether the flight's cancelled or whether the departure has been delayed, I'm only going to know that information on the day, the actual time of the flight. So it's not valuable to add those to my model. So I add those there, and then I just join it up with the rest of my flow here. And then I hit submit, and it would take about 15 minutes to run, and this is what the result would look like. So here you can see got green ticks showing all the constituent steps ran correctly. And then here I can review the scored model. So let me just preview that data. And here you can see arrival delay by 15. So this is the actual data, and this is my prediction. So here you can see my model accurately predicted that there was going to be a delay by more than 15 minutes. Here it predicted that there was going to be a delay when there wasn't. Here it predicted there wasn't going to be a delay when there ended up being one. But I can do this site test, but it's not going to get me very far because there's 700,000 rows. So I need to move to the evaluation results. And here I can see a sort of more aggregate view. So I can see that the most common instance is whenever both were 0. So whenever the model predicted that there was no delay and there was no actual delay. And you can see that 46,000 times it guessed correctly there was going to be a delay. but you can see there's more than a couple cases here where the prediction's been wrong. So again, it's a model that needs a little more refinement. You'd probably want to add in maybe weather would be pretty key to the model, just based on like if there's a snowstorm, more flights are likely to be delayed. It might add to the accuracy of the model. And then finally, moving away from AutoML and drag and drop to actual coding. So here we are in Databricks. And similar to the predicting rental price, I'm going to predict Airbnb prices in San Francisco. So here's my data set. I've got things like neighborhood, bathrooms, bedrooms, beds, and the thing I want to predict is here, it's price. So again, I'm going to do the same set of steps. I'm just going to write it in code instead of drag dropping or letting AutoML handle it. So I'm creating my training data set, my testing data set, 80% into my training, 20% into my testing. Then I'm going to do linear regression. So I'm going to select 3 features to train my model on, which are bedrooms, bathrooms, and review scores rating. So I think these 3 are going to have an effect on the eventual price of the Airbnb listing. So you can see here, I actually train the model on linear regression, which is one of the most simplest regressions, on my set of features to try and predict the price. And here, if you remember your 6th form mathematics, here is the actual formula that's the linear regression model has output from the training. So that's the formula that would actually be applied to the test data set. So when we apply it to the test data set, what you can see happening is we're feeding in these features and then we're getting a prediction. So if you look at rows 2 and 3 here, we've got 1 bedroom, 1 bathroom for both, and both have a score of 98. And then the prediction is $175 per night, which you can see is a decent prediction for row 2 and a less good prediction for row 3. Again, you want to be able to have some way to sort of aggregate that in terms of how accurate are your predictions on a whole. And for that, we use this evaluation at the bottom, which is root mean squared error, which is 147. So that's a good benchmark. But again, like the other models, you might want to iterate again. So I'd probably want to bring in the different neighborhoods of San Francisco or number of beds or property type. There's a lot more sort of features we can add that I think would help us improve the accuracy of this model. So hopefully that gave you a bit of an idea of those 3 different ways to help you get started. Obviously, they increase in complexity as you go. And then just some other advantages and disadvantages. AutoML is going to turn around your data pretty quickly. So you make a few connections, then you go away and watch TV while AutoML runs. 2 hours later, you will have an actual output. Whereas you have to actually create the flow with the drag and drop tool, and you would have to write the code if you were using a notebook instead and something like Databricks. So it's a longer turnaround as you go. It's also an increasing level of user intervention. More expertise is going to be required. So AutoML, you need very little understanding. Low code, you need a little more understanding, particularly of the process. And then coding, you need to understand the process and you need to understand the programming language. Then more towards the benefits of moving towards coding is that there's just more customization possible, particularly when you're trying to tailor your analysis to an actual business problem. You're getting feedback from the business, understanding it, being able to sort of make any alterations to the model you're creating or the flow you're creating can be really beneficial. And that's much easier as you move towards the right. And it's pretty much impossible with AutoML. You're pretty much stuck in your ways. It also allows easier explainability. So the very fact that you're more hands-on with the data allows you to explain the process a lot more. And that's really beneficial for the business. In any cases where, for example, if you just handed them an AutoML output, they'd be sort of questioning, the business would be questioning, okay, where does that come from? And then you can't really explain it. You just said, well, I put in this data set to an AutoML tool, and this is the output. Whereas actually, if you've gone through the process through coding or even through no code, you'll understand the process a bit more and you can explain how you've reached that outcome. And then finally, since this is the first in the series around stages of analytics, I will hint towards later stages. The best foundation to move from sort of initial experimentation like this to productionization would be to create these models using code as well. So just something to keep in mind there. And with that, thanks for watching this video. If you have any questions, my details are there. Feel free to reach out to me. I'll be happy to answer any of them. Other than that, have a great day.